So last week, I think you had your assignment, right? So I didn't call it as mid-semester examination because I thought that so it's good if we can do few assignments, at least two, right? Better. So after complete, have already completed the matrices part. So after completing the matrices part, we did a one assignment. So I hope to prepare another assignment when you complete the vectors part. So then we have two assignments, and also the assignment, the preparation for the assignment will be a part of the preparation for the final exam as well, right? So මම හිතනවා දැන් matrices ඉවර කරලා අපි assignment එකක් ගත්තා. ඒ වගේම vectors part එකත් ඉවර කරලා අපි එහෙම assignment එකක් කරොත් හොඳයි. ඔයගොල්ලන්ට exam එකටත් ඒක prepare වෙන්න හොඳයි. So and from this March 7th onwards, we are going to conduct another sessions of examination, final exam. So do you have any exams? Yes, Nick? ඔයගොල්ලන්ට තියෙනව නේද exams? 1S1 I think, Nick? Hello?
Madam.
තියෙනව නේද?
Oh, madam, තියෙනවා.
Right, තියෙනවා. Right? So after completing the first semester, actually, there's a big gap. So that's why we straight away started the second semester. And after completing few weeks, we are going to conduct your 1S1 exam. So anyway, these days, so from my side, so you are having pre-calculus and coordinate geometry, right? So these days we are preparing the papers, right, for you, right? So please get ready. So you have to go through almost all the lectures that you have completed within the lectures. Apart from that, so you can refer any other questions, tutorials on the from the Google or any other reference books or whatever. But anyway, the first and foremost, the first thing is you need to go through the lecture materials. Lecture materials ටික හොඳට follow කරලා ඒකේ තියෙන questions ඔක්කොම ටික වගේ හදලා එන්න, right? So then you have confident enough to face for the exam. And also we'll available you the past papers, right? So actually, so the first before this year, actually our library has a digital past paper collection, but now we are moving almost all the past papers to the LMS, right? So as the LMS admin, so I with the collaboration of librarian, we created now the past paper repository and LMS. So very recently we are going to enable it for you, available it for you, right? Past paper collection එක දැන් LMS එකේ ඇදමින් පවතින ඔයගොල්ලන්ට past papers LMS එකෙම බලා ගන්න පුළුවන් වෙනවා තව ටික කාලෙකින් ඉඳලා, right? So therefore for you, I think several past papers for the pre-calculus and coordinates geometry are there, so you can refer them. So format is more towards same, right? ඔයගොල්ලන්ට තියෙන past papers දෙක හෝ තුනේ formats ඔක්කොම එක විදියට යන්නේ, and also this year paper is also developed on top of that format, same format follow කරන්නේ මම. So therefore first go through the lectures, do almost every question on the lecture notes, and then you have to do the past papers, right? So that is must. Past papers තියෙනවා නම් තුනක් හරි දෙකක් හරි ඔක්කොම කරලා ඉන්න, right? So it is good, right? So I request you to study as groups, right? Although you are not physically in the campus, you can create the online groups can be created, and so by yourself you can do the past papers and share whatever your answers with friends, right? Past papers තමයි ඔයගොල්ලන්ට hands on experience විභාගය ගැන ගන්න තියෙන හොඳම තැන, right? ඒ past papers කරන්න. Because and also so before the pre-calculus and coordinate geometry, for the very earlier two batches, for 16, 17 and 17, 18 batches, there's a different syllabus called complex numbers and coordinate geometry. අවුරුදු දෙකකට කරන අවුරුදු දෙකට ගියා complex numbers and coordinate geometry code එක එන්නේ IA 133003. IA 1003 කියන code එක යනවා complex numbers and coordinate geometry. That is also okay for you. ඒක refer කරත් ප්‍රශ්නයක් නෑ. ඒකත් refer කරන්න in addition to the past papers of IA 1204 and IA 1201 pre-calculus and coordinate geometry. ඊට අමතරව අරවත් refer කරන්න. ඒතර all together you have I think 5 past papers, right? So in the very previous syllabus IA 1003, so there it contained only the complex numbers and coordinate geometry. So in order to get a good exposure on the complex numbers, you better to do those questions along with the coordinate geometry. So the other questions related to logarithm, trigonometry, inequalities, those type of questions you can find from the very recent syllabus of past papers of IA 1201. Are the complex numbers, coordinate geometry විතරක් exposure එක ගන්න ඕගොල්ලන්ට පරණ syllabus දෙකේ papers බලන්න පුළුවන්. ඊට අමතරව අලුත් syllabus papers තියෙනවා. ඉතින් ඔක්කොම තියෙනවා, right? So it is very advisable to do the past papers, right? So first thing, go through the lecture and do almost all the questions. So assume that you do not have extra time. ලොකු කාලයක් නැත්නම් study කරන්න. So best thing is do the lecture notes and then do the past papers. So if you have more time than that, you can refer whatever the additional questions from the internet or as the reference book. තවත් වෙලා තියෙනවා නම් අනිත් දේවල් but the main thing is to cover first the lecture note, second the past papers, right? So that is for your information, right? I hope the other lecturers also will provide you necessary information regarding the exam. So I think you will recently get your exam timetable. Then accordingly you can plan your time and study for the exam, right? And it is a physical exam, so you have to come and write the answer for the questions physically at the faculty. So with these work, whatever the these stuff on this semester 2, with these things you need to consider on that thing also. And again, students, I am saying, since you are very fresh, since you are at the first year, right, try to score your marks from the first year, first semester onwards, right? So some might think that, so no, so there's some problems with the first year, first semester, I'll start from the first year, second semester. Or else some may think that, no, I'll start from the second year. මම වැඩ කරන්න ගන්නවා ඊළඟ semester එකේ ඉඳලා නැත්නම් මම වැඩ කරන්න ගන්නවා second year එකේ ඉඳලා එහෙමනම් හිතන්න එපා, right? So gradually the subjects are getting complicated, right? So then so therefore the first year, especially first year, first semester is the place where you can very easily score the marks. So try to score the marks as much as possible from the first year, first semester onwards. අපි දන්නේ, so we have the experienced students. Now we have worked with 5 batches, and so students unexpectedly they face some problems. Sometimes most of the students are hospitalized due to dengue, due to coronavirus, right? So therefore they miss the exams. එහෙම exam miss වෙනවා, right? So හදිසියෙ repeats වලට එදා exam එක දවසේ ප්‍රශ්න වෙනවා. So therefore කරන දේ හරියට කරන්න, and also don't try to put medical, right? Repeat medical දාන්න යන්න එපා හේතුවක් නැතුව, right? So when you come to the next year, so ඔයගොල්ලන්ට ඒතර next repeat exam එක මේ exam කරන්න උනා exam heavy බාල් ටිකක් තියෙනවා, right? So therefore don't do like that. Try to finish the exam of that particular semester on that semester itself. Exam එකේ semester එකේ exam එකේ semester එක ඇතුලේ ඉවර කරන්න, right? Don't drag it, because so we as the human and also with the environment of the country, we don't know what will happen. So therefore we need to get ready and do your work today itself. අද කරන වැඩේ අද කරලා ඉවර කරන්න පුළුවන් නම් හොඳයි, right? Okay, because now we have so you know that now our very senior most batch, ඔයගොල්ලන්ගේ ලොකුම senior අයලා කළා දැන් මේ February මාසයෙන් ඒගොල්ලෝ out වෙනවා. ඔයගොල්ලන්ගේ වැඩ ඔක්කොම ඉවරයි, right? So then at the finishing stage, now we can experience some problems. They are requesting for extension, some are going to badge miss, right? ලකුණු අඩු වෙනවා, GPA එක අඩු වෙලා මේ request එනවා. So මේව නොකර ගන්න ඔයගොල්ලෝ වග බලා ගන්න, right? Don't go to that end. right? So try to do your work today itself, then it will be easy for you. Right. So now, today we are going to start the second part of this lecture series, vectors. So actually we have completed matrices. So now the vectors, right? So what do you mean by vectors, right? So I always tell, so here actually I have altered the topic. So that the original topic of this particular course is vectors and matrices. So since I have done matrices first, I put the matrices part first and then vectors. So, I also told you that why I did matrices first, because in order, in the vectors lectures, we have some concepts where we need the matrices. So that's why we first complete the matrices and then come to vectors. Then, so what do you mean by vector first? And I think this definition, what do you mean by a vector? So you have come across many places, especially in physics, right? Other than maths, in physics, also you have learned what do you mean by a vector? Right? Vector එකක් කියන්නේ මොකක්ද? Right? So in Sinhala, what is the name for a vector? සිංහලේ අපි මොකක්ද vector කියන්නේ? Sorry, I don't know about the Tamil words. In Sinhala මොකක්ද මේ vector එකක් කියලා කියන්නේ? කොළමයි. සිංහලේ vector එකට කිව්වේ මොකක්ද? Anyone? මොනවද? Daishika, right? Okay. So when it comes to the physical quantities, right? In our environment, right? There are physical quantities, right? There are quantities called physical quantities. So mainly physical quantities can be divided into two, right? Physical quantities can be divided into two: scalars and vectors, right? Scalars and vectors. So what are scalars? Right, so most of the numbers that we are dealing with, so that is called scalar. And also, if you consider about the time, kale, if you consider about the temperature, ushnata, if you consider about the volume, density, mass, so all these things are what? They are scalars, right? So when it comes to the scalars, right, what do you mean by a scalar? Have a magnitude but no direction, right? විශාලත්වයක් පමණයි, නමුත් දිශාවක් නැහැ. So that is what you mean by a scalar. For example, if you get a number, for example, number 2, right? Number 2 is the magnitude. 2 is its magnitude. ඒකේ විශාලත්වය 2 කියන එක තමයි ඒකේ විශාලත්වය. So we know that for the number 2, there is no particular direction, right? And also mass. If you consider about the mass, the weight of your body, right? The weight of your body, right? ඔයගොල්ලන්ගේ ශරීරයේ බර ගත්තොත්, so it has a magnitude. So it can be 65 kilograms, it can be 80 kilograms, it can be 40 kilograms. So it has a magnitude. Foreign weight, so there's no particular direction. So then how about the temperature? Temperature of a body, right? It can be 37 Celsius, right? So it has a magnitude, but no direction. But when it comes to the vectors, actually, when we compare the scalars with the vectors, so the difference between scalars and the vectors are vectors, other than the magnitude, it has a direction. So, right, other than the magnitude. So, when it comes to the quantity, physical quantity called vector, it has both magnitude and a direction. Right? So, the examples are force, velocity, acceleration, displacement, you know that, right? When it comes to the velocity, right now, the vehicle is traveling on the road. Yes, for the vehicle, for the speed, there's a magnitude of the speed. Right? The vehicle is passing on the road with 60 kilometer per hour or 60 kilometer per whatever, right? So there's a magnitude, and also there's a direction. So the vehicle with that particular speed go on a particular direction. Right? And also when it comes to the acceleration, so that is also the same. The rocket is moving with this particular acceleration. So, and there's a particular direction, upward acceleration, right? Or you can call it with the certain direction, it's go on that direction with that particular acceleration. right? So likewise, so if a physical quantity has both magnitude and a direction, we call it a vector, right? So that is basically the difference between scalar and a vector, right? So representation of a vector. So actually, so in this basics vector, so I'm doing very simple things, right? Right, very basic parts, very basic concepts of the vector, and then gradually we'll move on to the some complex parameter, right? So representation of a vector. We already know that. Now we know that vector has both magnitude and a direction. So there should be two way to represent both magnitude and direction, right? Vector එකට magnitude direction තියෙනවා නම් magnitude එකත් අපි represent කරන්න ඕනේ direction එකත් එක්ක, right? Right. So if we consider this OP, right? OP line, right? OP line, or else, yes, we call it as a line, right? So the magnitude can be considered as, so the length of this particular line, right? OP කියන line එකේ length එක දිගෙන් අපි යාගේ magnitude එක විශාලත්වය කියනවා. So it can be 5 centimeters, it can be 7 centimeters, 10 centimeters, likewise. So that represent the length represent the magnitude. And what about the direction? So you can see this particular line has an arrowhead, right? As an arrowhead, it is pointing to a certain direction. So this arrowhead is the one who's indicating the direction of this particular line, right? So therefore, so this vector representation by arrow, right? Then, right. So now you can see the length. You can understand the length represent the magnitude, and also the arrowhead represent the direction. So normally, in order to represent the magnitude, right, we are using this mod operator. So OP line, the vector of OP can be represented. So they have represented it like this: simple A, on top of that small dash, right? It's like A bar, right? So this is the vector. And in order to represent the magnitude of this particular vector, so they have considered about the mod, or absolute. They are taking the absolute value of this particular vector, the mod, right? සමාන්තර රේඛා දෙකක් අතර vector එක දාලා තියෙනවා. එකෙන් අදහස් වෙන්නේ අපි සලකන්නේ magnitude එක බව. Right. And so you can remember, we consider about the unit vector, unit matrices, equal matrices, and zero matrices. Likewise, so here we are considering about unit vector, equal vector, and the zero vector. So what do you mean by unit vector? So you can remember about the unit matrix. So if it is a unit matrix or as an identity matrix, right? You can remember the square matrix where the principal diagonal, or almost all the elements along the principal diagonal are 1, 1, 1, 1. Right? If it is 2 by 2, 2 ones along the principal diagonal. If it is 3 by 3, 3 ones along the principal diagonal. Right? So likewise, so if it is a unit vector, the magnitude is unit, and can write it as like this. So excuse me for a while. Right. So next one is the equal vector, right? So first the unit vector, right? Unit vector. So the magnitude of the unit vector is can be unit vector can be represented as so the unit vector. So here we know that unit vector can be represented like so the magnitude of the unit vector can be represented like this, right? So next comes the equal vector, right? Equal vector. Vector is equal, right? In order to be equal vector. So if I consider about the matrix, in order, so let's say capital A and capital B are two matrices, right? So we said that these two matrices are equal based on which conditions, right? If we are saying two matrices are equal, so for that, what are the necessities for that? What are the necessities in order to make two matrices equal? Cool. Matrices දෙකක් equal වෙන්න අවශ්‍යතාවයන් මොනවද තිබුණේ?
Both magnitude and direction are
Same order.
Right. I'm talking about the matrices. Yes. One necessity is same order. What are the other necessities? Another one necessity is there. Another one necessity is there. Elements in the corresponding positions should be same, right? Elements in the corresponding positions should be same. So what is that? අදාළ තැන්වල තියෙන elements ඒ සමාන වෙන්නට ඕනේ. For example, if we consider this is as matrix A, right? So if A and B are equal, so for the in the B matrices also, so the first row, first element should be A, right? First row, second element should be B. Second row, first element should be C, and second row, last element should be D. Likewise, so the elements which are on the corresponding position should be equal. So that is for the matrices. In the vectors, right, to denote two vectors are equal, right? To denote that two vectors are equal, in order to denote that, so the magnitude and the direction should be same. Magnitude එකයි direction එකයි මේ හැමදේම සමාන වෙන්නට ඕන. Right? So magnitude and the direction should be same. And when it comes to the zero vector, null vector, whose magnitude is, right? Whose magnitude is 0. The unit vector එකේ නම් magnitude එක එකයි. The null vector එකක් වෙනකොට magnitude එක බිඳුවයි. Right? So null vector. When it comes to the null vector, so this particular magnitude should be 0. Right? So basically that is, so these are important vectors: unit vector, equal vector, and zero vector when you are dealing with the questions, basically questions of the coming under the vectors, right? Right. Next thing. Right. Addition of vectors, right? So in the matrices also we consider about the addition of two matrices. Likewise, addition of vectors, right? Addition of vectors. So let's think that let vector A, right? Vector A and the other thing, students. So from the previous slide, you understood that, right? From the previous slide, you understood that. So here the vector can be represented there like this, right? Likewise, so different reference books, they are indicating vectors in different ways. Some represent vectors like this. Some use just the dash. Some use a small arrow on top of the letter, right? Letter kuda podi arrow එකක් use කරනවා සමහර reference books වල, right? So either way it's correct, right? මේ මොකක් වුණත් මේක නිවැරදි, right? So here you can see, so either in the previous slide it's a small dash, but here it's a small arrow. So let A and B be two given vectors. So OA is A and AB is B, right? Think about the direction, right? So here you will see OA is A, not AO, right? AO nemei A, but OA. If we consider about AO vector, so then it should be minus A. OA කියන vector එකේ direction එක එන්නේ O සිට A දෙසට, right? From starting from A, it will go until A. So the direction is OA. If it is OA, so that is indicated by like this, the simple A along with the arrow, right? And also AB is B, but if you consider about BA, it is minus B, right? OA උනාට AO කියන එක ඍණ A, or නැත්නම් minus A. AB is B, so then BA is minus B. So then the vector OB is called the sum of A and B, right? එතකොට OA, AB. So then summation of OA and AB is OB, right? OB. So that is going to be A plus B. So if someone is asking about a BO, not OB but BO, then it is minus of this summation. මේ සම්පූර්ණ summation එකේ minus එක තමයි වෙන්නේ BO, right? So therefore, always when you are working with the vectors, very much consider about the direction. Direction එක හරි වැදගත්. Direction එක අපි හරියට follow කරන්නට ඕනේ. Then rectangular resolution of a vector, right? Rectangular resolution, I think, so when you are working, right, when you are dealing with working with the 3D coordinates, right? 3D coordinate can be Cartesian coordinate, can be spherical, it can be cylindrical, or whatever within any coordinate system, right? So when you work with in 3D case, right? So normally in 3D case we have three axes, right? X axis, Y axis, and Z axis. So these are the three axes, right? Right? X is here, then Y is here, right? Three perpendicular axes are there, right? Three perpendicular axes are there. Y is here and here. Z is perpendicular perpendicular to both. No, this is X. Is it? So in the 3D coordinate system, X is there, Y is there, Z is there. So and they are perpendicular to each other. So along X, Y, and Z, so there's a unit vector going on. So sometimes you may heard about along the x-axis. So we are generally talking about the unit vector I, right? Along the y-axis, right? Along the y-axis, there's a unit vector called J. Along the z-axis, there's a unit vector called K, right? So these three unit vectors are going along each axis. So whenever you are measuring in some quantity along x-axis and any vector along x-axis, so it is I times the magnitude of the vector. So if you are considering about the y-axis, then J times the magnitude of that particular vector. And also if you are considering along the z-axis, then K unit vector times the magnitude of that particular vector. So basically මතක තියාගන්න ඕනේ මේ perpendicular axis වල වෙන වෙනම unit vectors යනවා, right? So whenever you are considering any point in the 3D coordinate system, you need to be consider about this unit vector as well, going along each axis, right? So here, so what you have to concentrate from this picture is this one. So if we are considering any point, so let's consider this is the point that we are considering in the 3D. right? When you make a point එක අපි consider කරෝතින්, right? So the coordinates are 3 coordinates should be there, x coordinate should be there, y coordinate should be there, and z coordinate should be there, right? So the magnitude of this, let's say this is P. So yes, this is P. So then the magnitude of OP means the length from O to P. Atara magnitude කියලා අපි මෙතන කියන්නේ O සිට P දක්වා තියෙන දුර, right? So that particular magnitude can be calculated from square root x squared plus y squared plus z squared, right? Square root x squared plus y squared plus z squared. So along each axis, what is the x component, y component, z component. So you need to square each component, get the summation of that, and finally get the root of the summation, right? So that is the magnitude. අපි 3D environment එකේ define කරන ඕනම ලක්ෂයක magnitude එක එහෙම නැත්නම් අපි කියන origin එකේ from the origin to that point, what is the length, right? Can be considered like this, right? So next thing is right. So there's any vector. So here then අපි ඔයාලට පේනවා මෙතන so the coordinate එක අපි සාමාන්‍ය xy coordinate system එකක උනත්, right? So in xy coordinate system එකක උනත්, if we consider about this point, so now I considering about this xy, මම මේ xy කියන plane එක විතරක් consider කරොත් අපි මෙතන අපේ coordinate එක දෙනකොට අපි x coordinate එක වෙනම කියනවා, I y coordinate එක වෙනම කියනවා, right? So that is the way, right? Likewise, so same theory apply to the 3D case also. So there's additional coordinate goes along z. So x, y, z is there. So this is the coordinate representation. But if someone asks, what is the OP vector? OP vector ka මොකක්ද කියලා ඇහුවොත්, or else, so they are representing the OP vector as R, right? What is R? So this is actually this is how we are writing the vector. මේක තමයි vector එක ලියන විදිය. Right? So x is the coordinate that we are taking from with respect to x-axis. X කියලා කියන්නේ x අක්ෂයට සාපේක්ෂව අපි ගන්න measurement එක. So this is y along y-axis, this along z-axis. So all together, so since R is a vector, එතකොට මේ x වලින් represent වෙන්නේ it's like a magnitude. y. එතකොට x අක්ෂය දිහාවට කොච්චර ගමන් කළාද? y අක්ෂය දිහාවට කොච්චර ගමන් කළාද? and z අක්ෂය දිහාවට කොච්චර ගමන් කළාද? So in order to convert this to a vector, right? So we need to multiply each component of this particular scalar along each axis with its unit vector. So x අක්ෂය දිහාවට තිබ්බ unit vector එකයි. So here I told you along x axis the unit vector is I. So let's say x is 2 times I. So then 2i is a vector, right? 2 is a scalar, but 2i is a vector. So then let's say y is a 3, so 3j. So along y-axis, the unit vector is j. Y-axis දිහාවට තියෙන unit vector එක j. So yj and also same as zj. So altogether, if you get the summation xi plus yj plus zj. So the first thing that you need to remember that මෙතනින්ම from this slide onwards, so we can create a question, right? මෙතනින්ම ඔයගොල්ලන්ට question එකක් දකින්න පුළුවන්. For example, in your question paper, you might give a point on a space like this. 3D space එකේ point එකක් මෙන්න මෙහෙම දෙනවා. Let's say this is point එකක් දෙනවා 2, right? So you have given a point. Right, you have given a point, say 2, 3, 4, right? 2, 3, 4. So this is the point that you have given. Point. So then they ask, so what is the represent? So we will say this is P, right? This is the point P, right? So they are asking, what is, so this is the coordinate point, and what is the vector corresponding to P, right? What is the position vector of P? So then you have to write Pi plus 3j. So let's say they're asking about the position vector with respect to the origin. Origin means 0, 0, 0 කියන origin එකට සාපේක්ෂව what is the position vector of P, right? So then, so you have to write 2, 3, 4, 2i plus 3j plus 4k, right? 2i. So make up with respect to origin, right? So they're asking about the position vector of P with respect to any other point. Ek origin name 0, 0, no one point make concept but Amela position vector 0 vector 0 in a position vector 0, 0 key so this is 2i, right, plus 3j plus 4k. Okay, so this is the vector. This is the position vector of P. So now as the next question they're asking, what is the magnitude? What is the magnitude of this vector, OP vector? What is the magnitude of the OP vector? So what is the magnitude? The OP vector ke magnitude එක මොකක්ද? කොහේද? Anyone? So you can put the answer to the chat as well. So what is the magnitude of OP vector? What is the magnitude of OP vector? Vector එක තමයි දැන් මේ දීලා තියෙන්නේ. P with respect to origin, the position, so the vector is 2i plus 3j plus 4k. So then what is the magnitude of this particular vector? Root 29. Root 29. So or else, so one has said me it is 5.38. Good, right? 5.38. කියන්නේ magnitude එක හොයන්නේ කොහොමද? මෙන්න මේ equation එකට දාලා. Within square root x squared plus y squared plus z squared. So then 2 squared plus 3 squared plus 4 squared. Right? So then, so you will get the root of 29. Right? You see now my root. Right? So from this one is from this, even from this slide, so you will be getting a question like this. You will be given the points, 3D points, then you are asked to write the vector and also you are asked to calculate the magnitude, right? Calculate the magnitude, right? So then apart from that, so here is another question that you will usually get, right? So this is the vector name vector out of this coordinate point 2y plus 3j plus 4k. So then unit vector. So normally there are some certain questions where you need to, after finding the vector, you are asked to find the unit vector of that particular. So if I ask, what is the unit vector along this of our vector? Make a coordinate corresponding vector unit vector. In order to do that, unit vector vector is going to be divided by its magnitude. Vector is going to be divided by its magnitude. So this is going to be divided by its magnitude. Magnitude see, name vargamule. Right? So this is the unit vector. This is the unit vector of OP. Right? This is the unit vector of OP. Right? So if you go back. So now you can remember, right? You can remember along each axis, along x-axis, along y-axis, and along z-axis. So these are the three major axes perpendicular to each other. May axis dige alata awenika unit vector එකක් තිබුණා. For each of these axes, there are unit vectors endemic to them. Right? For example, there's a unit vector along x is I, along y that is j, and along z that is k. යාලගේ දිග යන යාලගේ unit vector එක තිබුණා. So now we are asking what? Right? අපේ OP කියන vector එක තමයි මේක. මෙන්න මේ දිගේ යන unit vector එක මොකක්ද කියලා තමයි අහන්නේ. What is this? Right? What is the unit vector along OP direction? Now you can, even from the picture, you can understand whatever the unit vector here should consist of both x altogether x, y, and z. And I, J and K. එතකොට මේ කියන යුනිට් වෙක්ටර් එකට මේ I, J සහ K කියන තුනෙන්ම contribute වෙන්න ඕනේ. මොකද මේක තියෙන්නේ X, Y, Z කියන අවකාශය. ඒතර X की unit vector එක I, Y की unit vector එක J, Z की unit vector එක K වෙනකොට, so in order to create the unit vector going along this vector OP, so then what we are doing, in order to construct that, what we are doing is, so our normal vector, so that is 2y plus 3j plus 4k divided by its magnitude. So in our case, it's 229. So this is the unit vector along OP direction. This is the unit vector along OP direction. Right. So here is an example. If A and B be two unit vectors and alpha B angle between them, so then find the value of alpha such that A plus B is a unit vector. Right? If A and B are two unit vectors, A, B can unit vectors and alpha is the angle between them. So you can understand if A is a unit vector and B is a unit vector. If A is a unit vector and B is a unit vector, what is the magnitude of both A and B? Students, what is the magnitude of both A and B if they are unit vectors? A කියන්නේ unit vector එකක්ලු B කියන්නේ unit vector එකක්ලු. So what is the magnitude of them?
1.
1. Right. So if A and B are two unit vectors and alpha be the angle between them, then find the value of alpha such that A plus B is a unit vector. Right. So another thing, students, with this I will remind you something. Right. So your final paper regarding pre-calculus consists of since your first year consists of 5 questions. Right. Questions samane pahak tiyenawa. When you go to the second year, only 4 questions. So why we keep give you 5 questions when you are in the first year? Because we are giving a chance to drop one question out, right? Right? So in the coming exam also, which we'll schedule on March. So so in my paper, so there are 5 questions, but you need to answer only 4 out of 5, right? So especially in this paper, in this, so actually half of our lecture is matrix, half of our lecture is vectors. So both, you will get questions from both sections. So in the matrices, you saw that the questions of matrices, you saw that they are very lengthy. And also it will take some time to calculate. For example, if we consider about, if you are asked to calculate if you ask to calculate the eigenvector of a given matrix, right? Eigenvectors of a given matrix. So then first you need to find the eigenvalues and then you need to find the eigenvectors, right? And if you are asked to calculate the power of a particular matrix, first you need to find the eigenvalues, then you need to find the eigenvectors, you need to construct the P, and then out of that you need to do the diagonalization and you have to find the power of the matrices. So they are very lengthy and consume some sort of a time. But when we consider about the vectors questions, so they will take very less time actually, right? Very less time. But different types of questions are there. අපි matrices ගත්තොත් එකම questions type එකක් තමයි ඔයගොල්ලන්ට past papers බලුවොත් තේරෙන්නේ. නමුත් when it comes to the vectors, there are different types of questions are there. Different variations of questions. Question variation එක වැඩි. නමුත් ගන්න කාලය සහ කරන්න ඕන calculations ප්‍රමාණය අඩුයි. And also, every time whenever you are doing a vector related question, I ask you to draw the diagram. Most of the time, I'm not providing diagrams. You are the one who supposed to draw the diagram according to the explanation given in the question. So then it will be easy for you to solve the question. Samahara velata, although your calculations are wrong, but if the diagram is correct, so I will give marks for the diagram as well. Right? So therefore, so it is good if you can draw the diagram and then try to solve the vector related question, right? Whenever it's possible, draw the diagram. So it is advisable. So if that is, yes, so what is the answer for this example? Example 1. Anyone? Find the value of alpha such that A and B is a unit vector, right? A unit vector, B unit vector, and also A plus B unit vector. So then, what is the value of alpha? Anyone? So those who have complete, you can send me the answer via chat. All right, I got, yes, as you can see, one answer is there, 60. Any other answers? Okay, 45 degrees, 2 answers are there. 60 degree is 1 answer, right? With that suggestion, so we'll move on to the, again, 45 degrees, we'll see. So this is a explanation actually. Right, as you can see, so they have drawn the diagram, right? They are going to paint a diagram, right? So they have drawn the diagram because through the diagram, we will be able to understand the scenario very easily, right? Rather than having the diagram on our mind and try to solve on the paper, right? So solution, so they are saying both A and B are unit vectors and also A plus B is also a unit vector. So then what is alpha? Right. So OAB alpha, B unit vector. So let's say OA. So this is OA and that is A. Right. So then AB is B. So this is AB is B. That is also a unit vector. And they are saying alpha is the angle between A and B. Alpha කියන්නේ A සහ B අතර තියෙන angle එකලු. Right? Right. Alpha is the angle between A and B. Right. So if OB කියන්නේ, right? So we know that. So the data provided with related to OA and AB, OA A බවත්, AB B බවත් අපිට දීලා තියෙනවා. And also they have provided alpha is the angle which is in between A and B, right? So they are saying, so next, so this onwards we are considering OB is C, හිතනවා OB කියන්නේ C න. හරිනේ අපි දන්නවා OA AB. So now OA is A and AB is B, right? So this direction and then this direction. So altogether OA is A and AB is B. So then altogether OB. එතකොට අපි OB කියන direction එක ගත්තොත් ඒක තමයි A දන B වෙන්නේ. Right? And also we know that that is 1. ඒකත් එකයි. Right? අපි දන්නවා මේකේ magnitude එකත් එකයි, මේකේ magnitude එකත් එකයි, මේකේ magnitude එකත් එකයි. Right? Right? So then as we can see, right, as we can see, so it forms a triangle. It forms a triangle which is equilateral triangle. Right? සමපාද ත්‍රිකෝණයක් හදන්න. Right? Equilateral triangle because almost all the sides are same. So that is 1. Right? So then OBA is an equilateral triangle. සමපාද ත්‍රිකෝණයක්. Right? So therefore, almost all the angles within this particular triangle should be 60. හරිද? එතකොට මේ ඇතුලේ තියෙන triangles වල ඔක්කොම කෝණ වෙන්න ඕනේ අංශක 60යි. Right? අංශක 60යි. But so they are saying here, now you are wondering, then කෙනෙක්ට හිතන්න පුළුවන්. So in our question එකේ අපිට දුන්නේ A and B be two unit vectors and alpha be the angle between them. එතකොට A සහ B අතර angle එක තමයි alpha. Right? So the angle between A and B is alpha. Right? So some of you wondering, so why they have marked alpha here but not here? Metan alpha liyan natu, I metan alpha liwe. Anyone? Can you give me the explanation why? Right? So that is why on top of that basis that you have said me, so the angle of this alpha is 60. මේ අතර angle ඔක්කොම 60යි. So inside almost all the angles are 60. So you thought that alpha is also one of the angles out of there. That is why you told me. So the angle is 60. So anyone give me the explanation why they have marked alpha out here but not the inside angle? Inside acute angle එක නැතුව මේ outside මේ large angle එක alpha කියලා නම් කරේ ඇයි? Anyone? Anyway, definitely. So now you can consider that. So the alpha cannot be 45. So majority of the answers I reach is 45. So this cannot be. So either it should be 60 or 180 minus 60. එක 60 වෙන්න ඕනේ එක 180 වෙන්න 60 වෙන්න ඕනේ. 120. So you should tell me, or you should explain, or you should put your answers to the chat why they have marked alpha here but not here. You need to think. Right? So they are telling, so the alpha, right, and alpha be the angle between them. Alpha be the angle between them, right? So whenever you consider about this OA, right, OA කියන vector එක සලකුවොත්, right, you can extend this particular vector like this, right? You can extend this particular vector like this. So the alpha forms අපිට කිව්වේ OA සහ AB අතර තියෙන vector එක. So therefore they consider alpha as this vector. Right. So alpha is 25 divided by 3 or 120 degrees. Right. So next one, right? Associative law, right? Associative law, right? I think you can remember about the commutative and associative properties. So associative law means same concept as we have learned, right? So in associative, we consider about, in commutative, actually, we are considering about only two parameters, but when it comes to the associative, we are considering about more than two, right? So here they have considered about three vectors, right? The A, E, U, or as you can consider according to picture A, B, C, right? So then what they are telling according to the associative law, A plus B plus C or B plus C plus A, both are giving same answers, right? So that is in general. Then subtraction of vectors, right? Subtraction of vectors adu kirima, right? Vectors adu kirima. Actually, so A minus E, right? A minus E. So the idea behind that is A plus minus E, right? A minus E kiyanne ඇත්තටම. So we are going to add A and another vector minus C, right? Another vector which we has defined the other way around, opposite direction. So that is why minus come out, right? So then multiplication of vectors by a number. If n is a real positive number, right? For example, let's say n is 2, හිතමු n කියන්නේ 2යි, right? එතකොට 2 කියන්නේ real ඒ වගේම positive number එකක්. So the magnitude is n times a and direction is same as e. අපිට තියෙනවා vector එකක් a කියලා. දැන් අපි යනවා මේ vector එක දෙකෙන් වැඩි කරන්න. We are going to multiply this particular vector by 2. Right? So we know that 2 is a positive. එක කියන්නේ positive number එකක්. So therefore, if we multiply 2 with a, so then the magnitude of a has increased 2 times than a and all, but the direction is same. So දෙකෙන් වැඩි කර දෙක කියන ස්කේල් එකෙන් වැඩි වුණාම මොකද වෙන්නේ? a ගේ magnitude එක, right? a ගේ magnitude එක දෙකකින් වැඩි වෙනවා, right? The magnitude of a is increased by 2, but the direction is not changed. Direction එක වෙනස් වුණේ නැහැ, right? Direction is not changed. Right. So then, so what if we are going to multiply it by minus 2? Right. So now minus 2 is a negative number. It's a negative number. And if we multiply a particular vector by a negative number, so again, the magnitude is doubled. Magnitude double, but here in this case, the direction is opposite. Vector direction. Right. So that is the difference. So here in both cases, magnitudes are same. 2a. 2a is the magnitude. So the magnitude is not affected, right? But the direction has changed to the opposite direction when you multiply it by negative number. Right. Position of a point. Position of a point, position vector, right? Position vector, right? So the position vector of a point A with respect to the origin O is OA. Right? So here we are given a point, right? Here we are given a point, right? So then they are asking about the position vector of A. Position vector with respect to origin. So origin means, so if we are, let's consider we are in 2D case, 2D na, 0, 0 origin. Let's say this is 2, 1. We to make 2, 1 කියන coordinate, right? 2, 1 කියන coordinate. So therefore, now we are considering the position vector of A with respect to the origin. The position vector of a point A with respect to the origin O is a vector OA, which is used to specify the position A with respect to O. O ට සාපේක්ෂව A ගේ පිහිටීම, right? Position of A with respect to O. O ට සාපේක්ෂව A ගේ පිහිටීම. To find AB. Right? So likewise, so let's say the method of B අපි හිතමු තියෙන්නේ 1 3 කියන point එකේ කියලා. Remember this is my comma, right? Right? So here also the position vector of B with respect to O, right? Position vector of B with respect to O. So now to find AB, right? To find AB if the position vectors of point A and B are given, right? After venom position vector A, separately we have given the position vector of A and position vector of B and asked to find what is the position vector of AB. AB AB ki position vector right? So then with respect to OA and AB, we need to OA and OB, we need to calculate the position vector of AB. Right? So it's like this. Origin this is the O origin, right? And here is the vector called, this is A, this is vector A, and this is vector B. 2 points A and B. So now we are asked to find what is the position vector of AB with respect to O. What is the position vector of AB with respect to O? We are calculating the position vector of OA. Then we are calculating the position vector of OB. Right? Out of these two vectors, out of these two position vectors, we are going to calculate the position vector of AB. Right? That is basically what happened. Right? So AB is what? So අපි දන්නවා AB. අපි හැම වෙලාවෙම පටන් ගන්න මෙතනදී මේ වගේ calculation එකකදී so you need to concentrate about the direction of the arrowhead. Arrowhead එක දිහා හොඳට concentrate කරන්න ඔයගොල්ලන්ට පේනවා arrowhead එක යන්නේ A ඉඳලා B ට. A indala beta. So then we need to start from A, right? A. So then AB කියලා කියන්නේ AB කියලා කියන්නේ so we need to go this direction. අපි මේ direction එකේ යනවා නම් A O O B. It doesn't matter we are given OA. OA තිබුණාට so we are given OA. අපි දන්නේ OA නමුත් අපිට හොයන්න කියන්නේ AB. So we start from A and go in this direction. එහෙම යනකොට අපිට හම්බෙන්නේ OA නෙමෙයි but AO. Right? So AB means AO plus OB. Right? AO plus OB. Right? So AO plus OB. So likewise, right? So that's why the position vector of OA, position vector of OA right? So මෙතන විදියට නම් අපට එන්නේ OA plus OB. OA plus OB. එතකොට A කියලා කියන්නේ මෙහෙමම අපිට ලියන්න පුළුවන්. So this again can be written as OB OB because we are provided OA and OB. අපිට දීලා තියෙන්නේ අපිට OA දීලා නැහැ. So we are not given OA. Can you see? We are given OA is equal A and OB is equal B. Right? So but actually the AB position vector කියලා කියන්නේ OA plus OB. So we know OB. අපි OB ව දන්නවා. Right? OB කියන්නේ B. But we do not know OA. What is OA? AO. Right? We do not know AO, but we know OA. අපි දන්නේ AO plus OB. තමයි AB කියන්නේ. නමුත් අපිට දීලා තියෙන්නේ OA. නමුත් අපිට හොයන්න ඕනේ AO. එහෙනම් AO නම් in order to convert OA to AO, we need to multiply it by minus. So finally, this will become B minus A. ඒ නිසා තමයි මෙතන කියන්නේ AB කියලා කියන්නේ AB කියන්නේ position vector of B minus position vector of A. හරිනේ? Position vector of B minus position vector of A. Right? So every time you need to concentrate about the direction. Right? Although they have asked AB කියලා කියන්නේ AO plus OB නෙමෙයි. But OA plus OB නෙමෙයි because we are given OA and OB. But it is AO plus OB. So AO means minus OB, right? That should be, so that is the position vector. So the concept of position vector is very important. You need to clearly understand that. Right. So next one is ratio formula, right? Ratio formula, I think under the coordinate geometry also we have learned about this ratio formula, right? Under the coordinate geometry also we have learned about this ratio formula. It's like, so I think you can remember. So there's a particular line called A and B, right? A and B. There's a particular point called C in between. So C can be in between AB or outside AB. So let's see. So it's in B, and so this particular C point is going to divide this AB line into M to N ratio, right? So then how you can find the position vector of C? C ගේ position vector එක හොයන්නේ කොහොමද? අපිට දීලා තියෙන්නේ දැන් මෙතන තමයි O origin එක තියෙන්නේ. Right? This is the O origin. So what they are asking is to find this thing, OC. අපිට හොයන්න කියන්නේ OC. Right? But what we are given, actually what we are given is අපිට OA දීලා තියෙනවා. Right? So that is A, OB දීලා තියෙනවා, that is B, and also they have provided this particular C point is going to divide this AB line into M to N ratio. මේ ඔක්කොම දේවල් පාවිච්චි කරලා we are asked to find what is the position vector of OC. OC හොයන්න තමයි අපි OA සහ OB දෙන්නගේ උදව් ගන්න. Right? So as you have learned under the coordinate geometry, so M times, right? So let's say this is B and this is A. So here also the direction is important. Actually, OA is going to be A and OB is going to be B. Right? So then M times B plus N times A divided by M plus N. So this is the position vector. This is the position vector of OC. Right? This is the position vector of OC. Product of two vectors. So under the vectors, this is also one of the very important part, right? Product of two vectors. මේ vectors දෙකක product එක නැත්නම් ගුණිතය. Right? So when it comes to the multiplication in between two vectors, there are two types. Right? There are two types. Vectors multiply කරන ප්‍රධාන ක්‍රම දෙකක් තියෙනවා. So one is a scalar multiplication, or අපි කියනවා dot multiplication, dot product. The other one is vector multiplication, or අපි කියනවා cross product. Right? Two types of multiplications are there. Scalar multiplication or dot product, vector multiplication or cross product, right? So the product of two vectors result in two different ways. The one is number and the other one is scalar. So we call this is මේ තමයි dot product එක. Right? එහෙම නැත්නම් අපි මේකට කියනවා scalar multiplication. එතකොට මේකෙන් output වෙන්නේ as a result of this dot product or dot multiplication, we get the output which is a scalar. මෙතනින් හැම වෙලාවෙම output වෙන්නේ scalar එකක්. Right? Although A and B is a vector, A, B දෙන්න vectors දෙන්නෙක් වුණොත්, but if we are using the dot product or as the scalar product to do this multiplication, so always the outcome is a scalar. So, but when it comes to here, so this is the A, B, both are vectors, and if we use the cross product or else vector multiplication, always this output a vector, right? මෙතනින් scale එකක් එළියට එනකොට මෙතනින් එළියට එන්නේ vector එක. Right? So both of these multiplications you should know. Scalar product or dot product. Right? Scalar product or dot product, both the topics are used for the same purpose. So if we consider about the equation එකක් විදිහට හිතුවොත් මේක තමයි ඒ equation. This is what you need to remember actually. මේක තමයි ඔයගොල්ලෝ මතක තියාගන්න ඕන. For the scalar product or else dot product, right? So A dot B is going to be equal magnitude of A or modulus of A, magnitude of B or modulus of B times cos theta. So this is how we are going to use. So if we are considering about geometrically, අපි geometrically හිතනවා නම් මෙන්න මෙහෙම තමයි එන්නේ, right? So A OA. So the position vector of OA is A, the position vector of OB is B, and theta is in between them, right? Theta is in between them. So then so if we are going to multiply A and B, or A and OB, A dot B, using the scalar multiplication, so this is how it's going to be modulus of A multiplied by modulus of B times cos theta. Right. And the other thing that they are telling is the scalar product is commutative. Scalar product එක commutative lu proof කරලා පෙන්නලා තියෙනවා. Commutative කියලා කියන්නේ මොකක්ද අපි? So when it comes to the addition, commutative කියලා කියන්නේ A plus B is equal B plus A. A ධන B එකතු කරාත් එකයි B ධන A එකතු කරාත් එකයි. So when it comes to the matrix multiplication, is it commutative or not? Matrix multiplication එක commutative ද නැද්ද?
No.
No. Yes or no then? It's not commutative, right? So that is straight away that you need to remember matrix multiplication is not commutative. අපි කිව්වා A multiplied by B, A matrix multiplied by B matrix is not always gives us B multiplied by A. So the results are too different, right? So, but there is a special case where A multiplied by B equal B multiplied by A in the matrices. What is that case? A වැඩි කිරීම B සමානයි B වැඩි කිරීම A නොවන එක අවස්ථාව, violate වෙන එක අවස්ථාවක් තිබුණා. මොකද ඒ අවස්ථාව? Normally A multiplied by B and B multiplied by A is not equal in the matrices. But there is one such occasion where both sides are equal. What is that? එක අවස්ථාවක් තිබුණා A වැඩි කිරීම B සමානයි B වැඩි කිරීම A වෙන. I am asking what is that?
Multiply by a unit matrix.
Multiplied by unit matrix. Right. Apart from that, another situation. There is another. This is not the answer actually I expected, but this is also can be considered. But there's a very special case where A multiplied by B is equal B multiplied by A. What is that? This is obviously අපි සාමාන්‍යයෙන් in real world also එකෙන් වැඩි කරාම matrix world එකේ unit matrix එක තමයි අපේ real world එකේ එක. ඕනම සංඛ්‍යාවක් එකෙන් වැඩි කරාම ඒ සංඛ්‍යාව තමයි එන්නේ. So this is obvious. But there is a special case where you get the commutative property true in matrices. What is that? Yes.
The matrix.
Yes. So from the chat also I received the same answer. When a particular matrix is multiplied by its inverse, so then A multiplied by B, so then B, when the B is become the inverse of A, right? So in that situation also commutative property holds in the matrix, right? So therefore when it comes to the vectors, commutative vectors wala two types of multiplications are there: scalar and the vector multiplication. But here, now we are in the scalar multiplication. So always scalar product or dot product is commutative. That means A multiplied by B is equal B multiplied by A. Why is that? So you know that A multiplied by E is AB cos theta, right? And then B multiplied by A කියලා කියන්නේ B modulus, A modulus. So AB අතර තියෙන theta නම්, right? If in between A and B, if the angle is theta, එහෙනම් අපි BA දානකොට අපිට theta ම දාන්න බෑ. Right? So අපි කියනවා in between A and B, the angle is theta. But here we are multiplying not AB but BA. එහෙනම් BA අතර තියෙන angle එකනේ අපි දාන්න ඕනේ. So then we need to put the angle in between B and A. Right? B and A. So then that is make a theta now, make alpha. Alpha is or else we can consider about minus theta. එක minus theta කියලා ගන්න පුළුවන්. එහෙම නැත්නම් in theta. Right? So then it's minus theta, and but you know that minus theta is going to be equal again cos theta as well. Cos minus theta is equal cos theta. Right? Cos minus theta is equal cos theta. So then again we know that එතනත් එන්නේ AB cos theta ම තමයි. So therefore A dot B is equal B dot A. So here they are considering the geometrical representation of dot product. අපි ඉගෙන ගත්ත dot product එක. The dot product කියන්නේ A dot B කියන්නේ A modulus of A modulus of B cos theta. So the geometrical interpretation of dot product, right? The scale, make it geometrically, geometry of value. So when we look at this dot product or the scalar product with the perspective of geometry, the scalar product of two vectors is the product of one vector and length of projection of the other vector in the direction of the first vector. A dot B කියලා කියන්නේ ඇත්තටම OA. So what is OA? OA time OB cos theta. එතන OB cos theta. OB cos theta කියලා කියන්නේ length of projection of the other vector in the direction of first. එතන මේක තමයි projection එක. එතන length of A එතන අපි මෙතන ගන්නේ A mod B mod cos theta. Cos theta, right? So here, එතකොට length of A කියලා කියන්නේ A mod කියලා අපි සලකන්නේ length of A තමයි. A mod magnitude එක විතරක්. එහෙම ගත්තොත් ඒක length of A. එතකොට B cos theta කියලා කියන්නේ what? B cos theta. B cos theta කියලා කියන්නේ, right? As you can see, B cos theta. එතකොට B cos theta කියලා කියන්නේ actually B කියලා කියන්නේ OB times cos theta. Cos theta එන්නේ මොකද්ද? Cos theta එන්නේ ON divided by OB. ON divided by OB. එතකොට OB ට OB මෙතන ඔයගොල්ලෝට පේනවා cancel වෙලා යනවා. ඇත්තටම මේක ගත්තොත් මෙතන තියෙන්නේ OA multiplied by ON. Right? ON. ON කියලා කියන්නේ projection of B along A. Projection of B along A. එතකොට A උඩ තියෙන B ගේ projection එක තමයි මේ ON කියලා කියන්නේ. So this is the geometrical representation of the dot product. Right. So these are the important points to get. Right. So actually these are the important results. These results are very important for the dot product. For the scalar products, you should remember these things. Calculations so what you can do is, right, rather than learn by heart, right, so you can have a particular trick where you can remember all these things. First thing is the dot product එක කියන්නේ මොකද්ද? What do you mean by dot product? Again, I'm reminding you that is A, B, cos. I'm say let's x. මම හිතනවා එක x කියලා මට හිතමු දාන්න හැ. අපි හිතමු. එතකොට A mod or the B mod cos x. Right? So මේ dot product වල අපි හැම වෙලාවෙම deal කරන්නේ cos එක. Right? So later on you will understand when we go for the cross product or the vector product එකට ගියාම එතන තියෙන sign. Right? There you will experience sign. But here under the dot product we are always dealing with cos. And also you know that cos wala lamai cos bindu kiyada. What is cos 0?
1.
Cos 0 1. And cos 90 kiyada.
0.
Cos 90 0. මෙන්න මේ දෙක තමයි ඔයගොල්ලෝ මතක තියාගන්න. මතක නෙමෙයි මේක ඔක්කොම දාන්න already. You know this already. Right? So what you need from this thing you can remember everything. And මෙන්න මේ දෙයින් ඔයගොල්ලන්ට මතක තියාගන්න පුළුවන්. ඇත්තටම so when you are doing calculations, right? When you are doing calculations, you have to work deal with like this. ඔයගොල්ලන්ට එනවා what is I times I. Right? What is J times J? What is K times K? එකම ಜಾති unit vectors දෙයක් වැඩි කරොත් what will happen if we multiply same type of unit vectors I J J K K එකම ಜಾති unit vectors දෙයක් වැඩි කරොත් මොකද වෙන්නේ? Right? And also what will happen if we multiply different types of unit vectors I J J K K I? What will happen if we multiply different types of unit vectors I J J K K I? Right? So as you can see එකම ಜಾති unit vectors දෙකක් වැඩි කරනවා කියන එකෙන් අපිට අදහස් වෙන්නේ මොකද්ද? What do you mean by multiplying same type of unit vectors? දැන් අපි ඉගෙන ගත්තා I, right? If we consider about I or any vector same vectors දෙකක් අපි සැලකුවොත් right? අපි කියනවා AA. Right? AA. These vectors are same. Right? In order to be two vectors same, what are the conditions? Vectors දෙකක් සමාන වෙන්න මොනවද තිබුණු conditions? Hello students, what are the conditions in order to be two vectors equal? Oh.
Direction and magnitude are same.
Huh? Sorry, I didn't get.
Both direction and magnitude are same.
Both direction and magnitude are same, right? So that may A same vectors, magnitude එකත් සමානයි, direction එකත් සමානයි. So then we can consider A. So let's say this is A, right? And also this is also A. So two vectors, both direction and magnitude are same. So if I'm going to multiply these two vectors, right? එතකොට මම යනවා මේ දෙන්න multiply කරන්න dot product එකකින්. What I am going to do is I am going to apply dot product in between these two. So that means A modulus of A dot A. So that means modulus of A multiplied by modulus of A multiplied by cos theta. So my next question is, what is the theta behind these two vectors?
0.
0. Right? Because these two vectors are parallel. Make a parallel and vectors dekha. So when there are two parallel vectors are there, definitely they are not meeting up. So then therefore the angle between these two vectors is 0. Right? Angle of this. So likewise, so can you remember what is I? I is the unit vector along x-axis. අපි I කිව්වේ මොකද්ද? x-අක්ෂය දිගේ තියෙන unit vector එක. So this is x. Let's say, let's remind, this is y. And this is z. Right? So what is I? I කියලා කියන්නේ මේ x අක්ෂය දිගේ along x-axis. This is the unit vector I. Right? So one unit vector is there. There's another unit vector is there. So we are going to multiply these two, right? So then again, what is the magnitude of the unit vector? What is the magnitude of any unit vector along this three-axis? What is the magnitude of any unit vector? So along x-axis I, along z-axis k, along y is j. So what is the magnitude of I, j and k?
1.
1. Right. So, so when we apply I dot I to the equation, modulus of I times cos theta is 0. Cos 0. Right. So then, if we apply to the equation, the I dot I is going to be equal modulus of I 1 times modulus of I 1 times cos 0. So then what is the answer? What is cos 0? 1. There are 1 times 1 times 1. Answer is 1. So this is same as you multiply j dot j. J dot j by dot make a. What is the modulus of j? 1. What is the modulus of next j? 1 times cos 0. So the answer is again 1. So this is applied for the k as well. K dot k equals 1 dot 1 dot cos 0, which is equal 1. Line. So therefore, can you see I dot I 1, j dot j 1, k dot k 1. So this is how it comes. The angle between same types of vectors are 0. Right. So my next question is, what will happen? Right. I dot j. Now different types of vectors are coming. So what is the angle between I dot j? Sorry, I and j. I saha j atar තියෙන angle එක කීයද?
90.
Why 90? I අපි 90 කියන්නේ මොකද? මේ x y and z are three perpendicular axes. මේ x y z කියන්නේ එකිනෙකට ලම්බක axis. එතකොට so so we are saying I is going on x direction, j is going on y direction, right? So this is j, right? So in between x-axis and y-axis, this particular angle is 90. 90. So therefore, in between I and j also the angle is 90. Angle like a 90, right? So therefore, so this comes. So then what is the magnitude of I? 1. What is the magnitude of j? Again 1. Cos 90. So the answer is what? The answer?
0.
0. Why? Because cos 90 is 0. Cos anuwa binduwai. Mekama තමයි අනිත් ඒවට. Right? This is I dot k. Right? When it comes to the I dot k, so that is also equal 1. Modulus of I is 1. Modulus of k is 1. Cos 90. That is equal. So likewise, k dot ij, ik and jk. Jk also same. So jk also answer is also, that is why ij 0, jk 0, ki 0. So here the summary is under the dot product or as a scalar product, if you multiply same type of vectors, answer is 1. If you multiply different types of vectors, answer is 0. So ජාතිය vectors unit vectors දෙයක් වැඩි කරොත් උත්තරේ 1යි. මොකද cos බිඳුව 1 නිසා. වෙනස් ජාති unit vectors දෙයක් වැඩි කරොත් බිඳුවයි. මොකද so the angle between these two are 90. Right. So that thing, right. So this is for the dot product. Right? This everything is for the dot product. Right? So you need to remember for the dot product, cos is there. So cos 0 is 1. So why cos 0 is coming when you are dealing with the same type of vectors because they are parallel vectors. So the angle in between them are 0. So when you are dealing with different types of vectors, the angle between them are 90. So then, yeah, this is right. So here next is vector product or cross product, right? Vector product or cross product. The vector or cross product of two vectors and B, so the vector cross product of two vectors between A and B is defined to be vector. So for the cross product, we make the equation. For the cross product, this is the equation. Right. So difference is A cross B is A modulus B modulus sine theta. Apart from sine theta, there's a new member is coming. This is a new vector. Make a තේරුම A vector එක වැඩි කිරීම B vector එක. එතකොට මේ eta කියන new direction එක කියන්නේ A සහ B ට perpendicular direction එක. Right. So you have the A vector. You have a B vector. So this particular new vector, new unit vector is going along a direction which is perpendicular to both A and B. A ටත් B ටත් perpendicular තලයක තමයි මේ කියන unit vector එක යන්නේ. So because of this unit vector, මෙන්න මේ අපට එන උත්තරය vector එකක්. Right? So from although we get මේ කොටසින් අපට ලැබෙන scale එකක් වුණාට let's assume that from this section we are getting 2. But when 2 is multiplied this particular vector, so again the final resultant will become vector. ඒ නිසා තමයි අපි මේකට කියන්නේ vector product එක. Right? So here under the vector product you have right, you have sine theta. Under the dot product or a scalar product you have cos theta එතන. දැන් මෙතන ඉන්නේ sine theta. And also the resultant that we got from this is a vector. So that is the difference. Right here, useful results of cross product. So like in the previous case, then මේ cross product එකේ මේ දේ මතක තියාගන්නට ඕනේ. Right, for the cross product එකට එන්නේ A cross B is equal A B sine I am putting sine x දානවා theta. A mod B mod sine theta. Right. So tell me what is sine 0? What is the value of sine 0?
0.
What is the 90? Sine 90?
1.
1. Then make අනිත් පැත්ත. Other way around when compared with the cos case. Right? Cos case එකට වඩා අනිත් පැත්තට දැන් මේක යන්නේ. Right? Here sine 0 0 and sine 91. Cos එකේදී cos 90 is 0 and cos 0 is 1. Right? Right. Okay. So here, so when we are going to multiply same type of vectors like II, JJ, KK, right? If these are same type of vectors, then definitely what is the angle between these vectors? II, JJ, KA. What is the angle between II, JJ, KK?
0.
0. So therefore, you know that sign 0 is 0. Although, so whether it's A, B mono, although A has a value, B has a value. So when you multiply both modulus of A and modulus of B with sign 0, altogether, the whole right hand side becomes 0. AB mono binduwen වැඩි කරපටි බිඳුවයි. ඒ නිසා when you multiply IIJJKK with the cross product, so the answer you got is 0. Right? In the previous case, කලින් case එකේදී IIJJKK, that is 1. But here in this case, IIJJKK, when you multiply using the cross product, the answer is 0. Right. Now, different vectors, ij, jk, ki, right? ij, jk, ki. So then the answer is 1, right? Not 1, since 90, right? So here we know that. So here when you go to the previous case, right? Same type of vectors, 1. For the different types of vectors, we always got 0. Right, but here it is different. The මෙතනදී වෙනස් වෙනවා අපිට when you multiply same type of vector 0 but different types of vector 1 වෙන්නේ නැහැ. Other than that you got k, I and j. For example, y අපි එහෙම කියන්නේ ඔයගොල්ලෝ මෙතන පේනවා a cross b කියලා කියන්නේ a mod b mod sin theta times eta. So this particular eta means the unit vector perpendicular to both A and B. A, B, eta, beta, දෙන්නට perpendicular වෙන vector එක තමයි මේ eta කියන්නේ. Right? So when we consider about I and J, මේ I, J ගත්තොතින් modulus of I, so again I'll write the equation. So I'm going to write I cross J. Right? I cross J is equal, what is modulus of I? 1. What is modulus of J? 1. So then sin theta. Sin. What is the theta here? Sin. What is the theta?
90.
Times eta. This unit vector. What is the unit vector? So here eta කියලා කියන්නේ unit vector perpendicular to both A and B. Then what is the vectors දෙක උනේ? I and J. What is the unit vector perpendicular to I and J? Tell me. A. Huh? Sorry, what is the answer? K. Right. So then let's solve this. 1 plus 1 multiplied by 1 can 1 sin 90 කියලා කියන්නේ again 1. 1 multiplied by 1 multiplied by 1 multiplied by k. So finally, our answer is k. Right. So that is I multiplied by j. So let's assume j multiplied by k. J multiplied by k is equal 1 multiplied by 1. Modulus of j is 1. Modulus of k is 1 times sin 90. So what is the perpendicular to j and k? Perpendicular unit vector to j and k? I. So then equal 1 multiplied by 1 multiplied by 1 multiplied by I. So then again, it is equal 1 times I. So that means this is the answer. Right, same as when you multiplied by ki, the answer is G. Now the problem occurs like this. Right, then ප්‍රශ්නයක් එනවා මේ විදියට. Right, so what will happen? Actually, what will happen if we interchange these two? මේ දෙන්න මාරු කරොත් මොකද වෙන්නේ? දැන් මම මෙතන අහන්නේ I and J. Right, I and J. So if I ask J multiplied by I, J multiplied by I means, what is the modulus of J1? What is the modulus of I1? What is the theta in between? What is the theta in between? 90,
90.
but 90. But the problem here is when you are defining, when you are giving the perpendicular unit vector perpendicular to J and I, so now it is direction change. That is not IJ but JI. Another direction එක මාරු වෙලා. So here you need to say so therefore there comes minus. So that's why here you can understand, right? So here you will see Ji is not equal Ij. Minus is coming out. And velama Ji samana ne Ij. Ji samana වෙන්නේ minus Ij. Ji is equal. J, the cross product between J and I is equal to the cross product between minus I and J. So that is you need to keep remember, right? The cross product of K and J is equal to minus cross product of J and K. Minus එකක් හැම වෙලාවෙම එළියට එනවා පැත්ත මාරුලා. Right? When the side is exchanged, the minus comes out. That is also you need to keep in. So especially I think you know do not need to keep these things in your head. That means you do not need to learn by heart. මේක කටපාඩම් කරන්න ඕනේ නැහැ. ඔයගොල්ලෝ මේ cos theta සහ sin theta ඔයගොල්ලෝ ඔළුවේ තියාගත්තා නම් ඒ දෙක විතරක් මතක තියාගත්තා නම් ඔයගොල්ලන්ට මේක ඔයාලටම ගන්න පුළුවන්. Right? Yeah. So then different types of so you have now you have learned about dot product and cross product, right? Dot product and cross product. Based on this dot product and cross product, we will be able to do some calculations, right? So here අපි මෙතනදී experience කළේ අක්කරම when it becomes unit vectors දෙකක් ගුණ කරනකොට, right? So when we are going to multiply or when you are going to take the product of unit vectors. But actually when we considering about a vector which consists of vector which has which incorporate 3 unit vectors. So let's consider about a point. So let's consider about a P point, right? So this P point is in the 3D coordinate system where it has both X component, Y component and Z component. So to make a 3D space එකේ ඉන point එකක්. එතකොට යාට X උත් තියෙනවා, Y තියෙනවා, J තියෙනවා. X, Y and Z තියෙනවා, right? This has X, Y and Z. Right? X, Y and Z. Right? So this, so the position vector. So let's say we are defining the position vector of P. A position vector එක ගන්නේ origin එකට සාපේක්ෂව. Right? So this is all right, origin එකට සාපේක්ෂව. So when we consider about the position vector of OP, right? OP, so the vector of OP, let's say this is A. Right? This is A and that A is here. Then A තමයි මෙතන ඉන්නේ. Right? Since it has X component, Y component, Z. අපිටම X කියන්නේ 2යි, Y කියන්නේ 3යි, Z කියන්නේ 4යි. So as I told you earlier, say whenever we are given a point, අපිට point එක දුන්නාම, coordinate එක දුන්නාම, we will be able to write down the corresponding vector. So අපි corresponding vector එක ලියන්නේ. So I said that X is 2, Y is 3 and Z is 4. එහෙමනම් 2Y plus 3J plus 4K. Right? So this is equal 2i plus 3j plus 4k. Right? So here actually x equals 2, y equals 3, z equals 4. Right? So this is our A. A කියන vector එක තමයි මේ. So B is another vector like that. B is another vector like that. Right? So when we ask to multiply A and B, when we ask to multiply A, B, it's not like just simply multiply two unit vectors. මෙහෙම අහන multiplication එක මේ තරම් සරල නෑ. So you know that when you multiply two unit vectors, we can simply write it as like this. මොකද unit vectors එක vector එකක් ඇතුලේ තියෙන ඒ unit vector එකම විතරයි. Within this particular unit vector, only I is there. Within this particular unit vector, only I is there. But when we comes to this case, right, within a one vector, all three unit vectors are incorporated. Here also within B vector, all three vectors are incorporated. At that situation, how we are going to multiply these two vectors? Right? How we are going to multiply these two vectors? Right? So actually, so there are cases where you will be provided to multiply only two vectors. සමහර ඒවා කියන vectors තුනක් දීලා තුනම වැඩි කරන්න. Right? So that so when it comes to the scalar triple product, so this is just vector product. Vector product again, the two vectors are given. You need to multiply using cross product. So here, three vectors are given. So that is called the scalar triple product. Two vectors have been multiplied with the cross, and the resultant of that is again multiplied with the dot or the scalar product. BC vector product එකෙන් ගුණ වෙද්දී ඒකේ output එක ආයි scalar product එකත් එක්ක ගුණ වෙනවා A වල. Right? So likewise, there are such cases like that. Right? So then how we are going to handle those cases? So different types of products or multiplications is available. So we'll talk about them next week. So today you learn about very basic concepts about the vectors, and so the things, how we are going to use this product, scalar and the vector product, you will learn next week onwards, and also about the differentiation, how you are going to differentiate using the vectors, how you are going to integrate, and some applications related to them will be learned from next week onwards. Right? Okay, students, I think last week also we missed our programming lecture because due to a total strike. So next week, no, not next week. Tomorrow also there's such case like this, but I will inform you sure. So whether we are going to have the lecture or not. So tomorrow also there's a strike like that. But now we have missed some programming lectures, so therefore we can't. We'll see what we can do. And the other thing is, I need to tell you about the assignment from the programming. So not this week, but next week, you will be having the first assignment of the programming. So get ready for that. So you need to go through the lectures. We'll complete uploading the rest of the lectures also. Right? Please go to study them and write your code by your own. So next week, you will be having your first assignment from the programming, and also it will be also a quiz-based assignment, right? So be ready for that. So it will be on next week, right? So thank you for joining with the lecture. You can send me the message now.
Excuse me, madam.
Okay.
Madam, අපිට මේ pre-calculus වල revision session එකක් යනවද?
Pre-calculus වල revision එකක් යනවද? Right, so that means 1S1 නේද? ඒක අපිට inform කරලා නැහැ. Revisions තියෙනවා කියලා අනිත් subjects වලට inform කරලා තියෙනවද හොසාරි?
P6 වල වගේ නම් කරනවා කිව්වා madam. අනිත් ඒවා නම් තාම අහන්න.
එහෙම කියලා නෑ. Right, මම බලන්නම්. මට පුළුවන් වුණොත් මම කරන්නම් definitely revision එක. Right?
Hi madam, thank you.
හරි.